We're going to look at two special right triangles, the isosceles right triangle and a 30, 60, 90 right triangle, and we'll explain that as we go along. The first is an isosceles right triangle. You remember about right isosceles triangles that the two sides, or the two legs, are congruent. We're going to label these like we do for the right triangle, but we know that this is also going to be equal to side A. There is a relationship with the hypotenuse for these. That hypotenuse is very simply A, length of A, times the square root of 2. Now I say, where'd that come from? I didn't just make it up. We apply our Pythagorean theorem, a squared plus b squared equals c squared. We then can do some substitution. We have a squared plus a squared is equal to c squared. Combine our terms. We then take our square root, both sides. So we have the square root of a squared is a, square root of 2 is equal to c. So it does work. We didn't just make this up. Now how do we apply that? Let's take a look at a triangle and let's say that side A is 6. How long is the hypotenuse? We can substitute where c is equal to a times the square root of 2. If a is 6, we simply substitute. C is 6 times the square root of 2. We don't have to apply the whole formula. We just know that relationship. Okay, what happens if we have a different size? I'm going to erase this one. And let's say if a is 5 times the square root of 2. Well, what happens? Well, we substitute in. C is equal to a times the square root of 2. We go with 5 times the square root of 2 times the square root of 2. We go, uh-oh, what's that? Well, we continue to multiply this out. We have 5 times the square root of 4. C is 5 times 2. C is 10. Simple enough. Work these out together like this. Simple substitution for the isosceles right triangle. The 30, 60, 90 right triangle is a little bit different, and we're going to label those angles. 30, 60, and of course we have the right triangle. Now we set it up the same way. We set it up. We're going to call this side B, this A, and our hypotenuse is C. Mathematical relationship, simple enough that C is equal to 2A, B is equal to A, the short side, times the square root of 3. We won't go through all the multiplication with this, but this same kind of setup works all the time for here. So let's take a quick look at a problem. Let us say that A is going to be equal to 9. We'd like to know how large the other two legs are. Well, we work through our substitution. So if we have C being equal to 2A, C then becomes 2 times 9. C is 18. The next one, we'll find out how large B is. We'll go right below B. A to the square root of 3. B is equal to 9 times the square root of 3. And we're done. So these right triangles are special. They have those numeric relationships. They often show up on tests. So have some fun with these. Work hard. If you have some trouble, talk to your tutors. And now get to work.